So who has never heard of Spack? Okay. Never. Okay. We use it to install stuff, like sometimes, or was using weekly, yeah. Was using it in production. We submitted a pull request with some package changes. Okay, 1, 2, 3. Yeah, okay. So power users. Okay, so I would start with who are we? I'm Massimiliano, and I'm a core developer of Spack since more or less 10 years. Before being a full-time core developer of Spack, I was working at EPFL, where I was responsible in Lausanne, in Switzerland, where I was responsible for deploying the software stack on the university HPC clusters. And before then, I was working here in CINECA, and that's why I know a few people. And then we have Harmen.
Yeah, so I followed Massimiliano's path, basically. So I started at CSCS in Switzerland as a scientific software developer, where I did like half my time on like internal automation of installation, etc., and half my time like actually working on scientific software. Until I started working full-time on Spack with Lawrence David Moore remotely. So I'm still based in Zurich. Yeah. Oh, yeah, an online presence, the avatar, you may know better than my face. So.
If you see us on GitHub, we look like this. Yeah, exactly. So I would just give some very high-level introduction to the project and then jump into some demo. Just feel free to raise your hand, interject, ask questions. So the first thing to say, but I think that given the crowd, everybody knows, what is Spack? Spack is a package manager to automate the build, the installation of scientific softwares on different platforms, ranging from your laptop to HPC clusters. It started being a from source only package manager, but nowadays, and since a few years, it also works with binaries. So you can produce binaries with Spack and then reuse them. I think the feature that makes Spack different from all the other package managers is that packages are parameterized. So when you install some software, you can constrain it the way you need it or the way you like it. Using a simple syntax, that is the Spack syntax, to express those constraints. Anybody that is not familiar, given the crowd, with the Spack syntax or need a refresher? Otherwise, I'll just move on. Yeah, exactly. We put that just for Kenneth. We generate, but we do not require environment modules. So Spack just install software. It can generate module files, either L mode or environment modules, but those are just byproduct of the installation. From the installation, you can generate many things, including module files. And it also has virtual M-like environments. So that's an overview of the core tool. The entire project looks like this picture. So that the Spack organization would be the big gray rectangle. And since Spack v1.0, more or less 1 year ago, we split the core tool, Spack as a tool, from the package recipes that live in another repository under the same organization. And those would be this block and this block. System administrators may be interested in the fact that for our CI infrastructure, we also have a repository to set up all the GitLab machinery. I won't go into much detail, in particular, because I won't be able to talk about that since I'm not the sysadmin. But if you are interested, it's there in the organization, and there is always people in our Slack channel that could help with that. And given this organization, there are a lot of projects that build on that. For instance, E4S, they basically build distributions on top of that. We have E4S from the University of Oregon. AWS is building some services on top of it. Of course, LLNL has its own stack, and so on and so forth. And especially for packages, we really rely on the entire community to provide contributions and expertise to many different domains. So this is the famous slide that Kenneth mentioned before. It's slightly updated, but the main point is that Spack is mature software. It's used in production worldwide at HPC sites. Contributions are coming from a broad range of institutions or individuals, and they're constantly increasing. So here you see the graph until 2023, and it's still increasing. And another thing that may be worth mentioning quite quickly is our user base. This time, instead of making claims, I'm just showing the result of the last poll we did. But what it shows is that the user base is also quite diverse. We have people that use Spack for their own project or on their own laptop or workstation, entire HPC sites that use it to build the portfolio of software that they give to their users through modules. And so we have really to satisfy diverse needs. Finally, I don't know if this is wide knowledge. Since a couple of years, Spack has its own legal entity. And since last year, I think it was last year, it's part of the Heights Performance Software Foundation, which is a foundation under the bigger umbrella of the Linux Foundation. That means that the Spack organization is a sort of a neutral organization for the tool. No single entity owns it. Spack development is steered by, it's driven by a technical steering committee, and we do everything in public. So if you want to join to see how decisions are made, the meetings we hold once a month are public, and you can just, log in into a Zoom call and listen to what is being discussed, or give your opinion if you feel like so. And finally, the last slide about our activity on the web. Of course, we are on GitHub and Stoppels there. We also have a Slack channel that is quite active with a few thousand users. And if you have any questions, just go there. The community is very welcoming, and there are good chances that you'll get answer within minutes. And besides that, we also have a few accounts on some socials that we use to, advertise new releases or events. And with that said, I think we are done, because what we'll try to do now is, instead of showing you basic concepts, we'll walk you through a demo. And to do that, we set up some instances on the web. So if you want to try it out, I'll give it some minutes. You can go to this. Did we share, Harmen, is it public? Like the link? Okay, so you can just go there and basically put your name in the table where you want to claim the user on the host, and you can SSH into some machine, like using the username as a password too, and you can follow along.
Or you should be able to add a field, but I don't see anybody doing it. So
yeah, no.
Yeah, okay. So like people can exit, just put your name into one of the cells, and then that means
exactly. If you want,
user free on this IP address, and you should be able to log in with SSH.
Yeah. Kenneth is claiming a lot of resources.
You're also not allowed to change the borders. You have to get them back. Can people log in?
Password is the same as the username.
If you're Spack 1, your username, your password is
It's Spack 1, and don't tell anybody.
Yeah.
Okay. So I'll just move on. And if you go to Spack tutorial, let's check. Let's go to the page where you would land. If you go to our tutorial web page, this is latest. This is for a full day tutorial on old version. You have to click here. You'll find CINECA 26 workshop, which is quite different from the usual tutorial. And Spack environments is the first thing I'm going to demo. So the idea of this demo, while I give you some more time to log in and set up, is that scientific software depends on a lot of details that could affect both usability and performance. And so to reproduce your environment, it doesn't suffice to give a list of packages to someone if you want to share the environment or to move it to another place, to another machine. What we are going to showcase now are the very basics workflow with Spack environments. A Spack environment is basically a way to define what you want to install and get a full specification of the details of that installation that can be versioned and that can be easily shared with other people or moved to other machines. And given the crowd, what we tried to do was basically to base the entire tutorial on Quantum Espresso. So the software we are going to install is Quantum Espresso. Oh, you have these basically tags on read the docs. You would land on latest, and then you have to pick CINECA 26 workshop.
And if you're looking for the page,
I am there.
Page just fine.
So, see you, mate. We'll have a beer later.
Sorry.
Yeah, I know. Bye.
If you're looking for the tutorial page, I think you should be able to Google Spack tutorial, and it should be the first hit. It's also in the spreadsheet.
Yeah. So once you're there, those are steps that I did already. By the way, if you want to follow on your own later, we also prepared a Docker image where you can perform the same, you can run the same demo. So to set up Spack, you just have to clone it and then source a setup script. Here, I already did it. So I have Spack already in my path. And then this step here is essential to register a mirror with all the binaries we'll use in this tutorial, because otherwise compiling Quantum Espresso can be, a good experience, but it won't fit the time we have for the tutorial. Well, you have to compile that. So, and we'll see reasons why easy may not suffice.
The tutorial talks about Docker. You don't have to use Docker. You can just run inside the SSH session.
Oh yeah, I gave it for granted. Docker is if later on you want to redo the tutorial.
Docker is for people at home.
Exactly. Yeah, sure.
Why are environments not?
Sorry?
Why aren't environments?
Why aren't environments?
They don't.
So you mean Spack, why Spack environments are not really
nice if they had a representation.
Exactly. Okay, so if people are set up, they should see something like that. If they do Spack compiler list, there should be GCC 15 recognized, and if you do Spack find, of course, you should see 0 installed packages. I guess we can start with the first task. So the first thing that I'll show you is how to create and activate environments, since those are two different operations, and deactivate environments. Those are really simple commands. If you give SpackAmp create my project, Spack creates an environment in a managed folder within the Spack instance, and already hints that you can activate it with SpackAmp activate my project. Once you activate it, once you create the environment, you can see that, that it's in the list. And once you activate it, Spack, sorry? Okay, by default, it places it in a directory that is within the Spack instance itself, but you can configure, which is something that we won't see in this, introductory demo. You can configure where environments are placed. Environments are basically two files. We'll see that later during the course of the tutorial. So there is a YAML file, which is a manifest containing all the configuration and the packages that you want to install, and then a log file for what I will show next, like the full specification of the things that are being installed. If you do Spack find, I was saying, and you have an environment active, you'll see that Spack find changes slightly. It mentions where you are. It says that you have no root specs. Root specs are the explicit request by the user. So far, we didn't make any explicit request. And of course, we have 0 installed packages and 0 concretized packages. So concretized packages, if you work with Spack, you know what they are. But in a few words, they're basically the full specifications of your request after our solver, which we finally named the concretizer, resolves all the details that you didn't specify. And yeah, it may be worth knowing that if you just want to know if you are in an environment or not, you can just say SpackAmp status, and it will tell you that you are in the environment my project. To go out of the environment, simply use this alias or SpackAmp deactivate, at which point you go back to the previous kind of output, and SpackAmp status says that there is no active environment. So far, so good. Just Yep.
Is there a reason why there's always exits with 0? Would it make sense for the state to do not 0 if you're not in an environment?
No, for status, I don't think that it should be non-zero if you're not in an environment. I don't know people, I don't know of any people that use that and distinguish on the exit code of SpackHemp status. Other commands exit non-zero for instance, SpackFind. If it cannot find a query, it exits non-zero. And yeah, so far, just simple stuff. Create and activate an environment. Let's reactivate the environment of my project. And let's do something a bit more interesting. If we want to install software in an environment, we have to proceed by step and first add the request to the environment, then concretize the request, and finally install the concretized stuff. We do things by step for a reason. So you have multiple safe belts if you want, and you don't jump directly into an installation that maybe was not exactly what you expected. If you do Spackhead, for instance, PyNumPy and Quantum Espresso, as shown here, those are the two packages that we want to install now. And then you proceed again with SpackFind. You'll see that now we have the two root specs. Those are the two requests we made, just PyNumPy and Quantum Espresso. To install them, we need to figure out all the details of the software. And for that, we need to concretize. This will take a few seconds. And if you did things correctly, it will basically pick stuff from our binary mirror. So once that is done, you'll get, hopefully, well, I'll just show it with SpackFind. You'll get SpackFind -C will show what is, SpackFind will say that we have 76 now concretized packages ready to be installed, but none is installed. If you want to look at the installation, you can either use Spack, which I won't do because my screen is too small to show it in a meaningful way. I can use SpackFind -C, which will show what is concretized. And here you see all the packages. Maybe let's try to query for PyNumPy, for instance. Here you see PyNumPy was concretized. When you use SpackFind, you can give some abstract specs, some constraint to refine what is shown. And the -C flag basically shows what is concretized and not what is installed. Now, the next step to install stuff is to say Spack install. And it shouldn't take a long time. So I just want to tell you that we are really installing Quantum Espresso, the real stuff. So it's just a matter of a few seconds from binaries. Done. Now, since we are in an environment, we'll go to using packages. We install Quantum Espresso. Since we are in an environment and we have the environment active, so Quantum Espresso is already in our path through the default environment view. And yeah, I couldn't find any good, well, I think, okay, maybe that's better. I couldn't find any good input, but as you can see, good input in the sense that just runs in a few seconds and doesn't require 10 files to showcase it's working, but this is like the executable. Yeah.
Is there a common to show the size of the packages like?
Oh yeah, that's yeah. We basically skipped for this short section on the very basics command, but you have Spack list. If you want to query which packages are available in the repositories that Spack knows about, so by default, Spack knows about its built-in repository. You can configure it to add on top of that also your custom repository. If you want to query those repository, you can use Spack list. And Spack list will basically show right now, if I do it, it will be a stream of 8,800 something packages. You can also place a query here. And you can query basically for part of a name. If you do something like that, it would be like globin with a star before and after. And so the packages that we have with Quantum Init are Quantum Espresso, by Quantum Elixir, and so on. And from there, which is another thing that is not in this tutorial, but maybe worth showing if you want to know something about the package. Once you located the package that you're interested in, you can use Spack info. Hopefully, the output will be readable. Yeah. Honestly, I'm a bit. How can I show it? Can I pipe it to last without like fucking up the mooks?
I think Control B and then up.
Control B up. Well, I'll try it.
You can scroll more. Or just use something else. Then.
That's fine. That's fine. But basically, if you use Spack info, you'll get a lot of information on packages. Okay. You get a lot of information on packages, like the version we know about, description of the package, all the options that you can use on the command line with the specs for that package, what they do, and so on. And so, as I was saying, to use the package, you don't have to do anything for simple environments that can project to the default view, because you have the view available when the environment is active. And when you go out of the environment, of course, the executable is not there anymore. I don't know if people could be interested in that, but by default, our views are just a projected symlinks to the place where we install stuff. So when we concretize, we basically construct a graph of all the dependencies with all the details, and that graph and all the details that go into the installation are hashed, and they represent uniquely the installation of that package. We install that package in an isolated way. Very similarly, that was bluntly taken from functional package managers. We installed it in an isolated directory somewhere in the Spack store. And what environments do is basically project those packages into a more standard file system hierarchy for your convenience. Yeah.
One question: how do we know in this case for which platform it has been?
Okay, so that you'll see from the spec or from find -l. Let me check what was the option. Yeah. Yeah, they are x86 64 bit-free. You can use either Spack find. It will show it here. If you want more details, you see that's like Linux. Ubuntu 26, and x86 64 v3. Oh, it's like a generic level. It's a standard generic. It's basically AVX2.
Okay.
But it's a standard generic level. Sorry?
Isn't there an alias defined somewhere? I thought there would be aliases for the levels.
Where? Like, you mean in
Start/lib/start.
No, we use ArcSpec for managing microarchitectures. And so the levels of generic x86 64 architectures are standardized. And since we run this tutorial, on x86 architecture, but we don't know exactly where it's done, we basically build it for a generic thing with AVX2. You can configure which target you want to concretize for, preferably, and that will be in configuration, not covered in this basic tutorial, but you can do that, and there are links to places that explain how to do that.
You could have added a package with an arc specifier, right, in the spec syntax.
Yeah. You can totally say, I want to install Quantum Espresso target equal x86 64 v3, or you can put in configuration, please, whatever you do to any package, prefer this target. That depends on your use case. If it's a one-off, it makes sense to do it on the spec when you install. If it's something that you always want for your environment, it makes sense to configure it more generally. But yeah. Yep. It doesn't cross-compile for different architectures. Yeah. So if I am on x86 64, unless you do X, we don't cross-compile. So sorry?
Gently, AMD, EPYC.
So on the x86 64 family, we can target whatever target, provided that we can run the build tools that are needed. But we cannot cross-compile across architectures or across operating systems, platforms. That's like a current limitation.
Maybe as an example, you could probably compile CMake targeting AVX512 and run it on the AVX2 machine because they're using those instructions. But I think already if you, for example, compile Python for AVX512 and try to run it as part of the build, you have to run some Python code as part of another package's build, it will likely fail already with like invalid instructions. So when we say we don't cross-compile, we just mean like you can target any instruction that your current CPU or your build on supports, but basically, as long as you have any build dependency that does not use any of those special instructions, you could get away with cross-compiling.
I mean, what we usually, we also use Spec for deployment on edge devices like Xilinx FPGAs that have an embedded ARM64 processor, which is rapidly into QEMU. Because you still need the large memory for compiling usually, but on these embedded edge devices, you don't have it. Yeah. And if you use Arcana or something like this, there is also the QEMU support nowadays.
Yeah,
so you
but
can just specify I want this container to be.
But that's fine. But then you have to run Spack on an emulated environment,
Yes, yeah.
Which, yeah, I wouldn't call it native cross-compiling.
Yeah,
we were doing that.
Because cross-compiling is never really working if your application doesn't support it. I mean, if it's supported by your setup, okay, but I think in general.
Yeah, no, that's fine, and especially if you go to edge devices, or Harmen was mentioning RISC-V, you'll probably get better build times. But if you target, I don't know, we had the case of targeting power systems, and we didn't have power machines, and we were emulating that on x86 64. That was like, I don't know, one order of magnitude slower than having the real hardware. But yeah, so, I would say that's all for the default views. If we can go back to this. Yeah, sure.
In this document now, you haven't made
At the beginning, one of the steps that I said were essential were, let me go back to the real beginning, is this one. Spack mirror add minus unsigned tutorial build cache. And as I said, Spack started as a from source package manager. It still is a from source package manager, but it also manages binaries. So to be able to get this tutorial going, we basically compiled ahead of time all the binaries that we will use here. And this command, Spack mirror add, points Spack to a set of binaries that we precompiled. And when we install stuff in the tutorial, we'll basically eat those configurations and just install from the binary. That's why it's so fast. One thing that I didn't show you, but I can just do in Spack fine. As you can see, we may change this output before Spack v1.2. You see that we have 40 installed packages, but 36, which are concretized but still to be installed. And those are the build dependencies. Like Spack is smart enough to understand that if what you want comes from a binary, there is no need to install CMake, no need to install, I don't know, autoconf and whatever, if you don't need to build the stuff. So those 36 are basically the build tools. We still keep the entire provenance of what we install, but if you're installing from binaries, you just install the runtime by default.
Another question.
Yep.
Is there a way to figure out what the mirror or the build cache provides in terms of OS, CPU?
Yeah, I think there is a command called build cache list. That one is off script, so let's see. All art. And that one should tell us all the things that we have.
In the cache.
In the mirror, yeah.
Okay.
Yeah, but there is a lot of overload in terms.
Slightly related question. What's your opinion on the usability of free caches? Not with the compiled script language, also like R, because they tend to put absolute paths in.
So what we
We
do?
can talk about it tomorrow. Actually, I will cover it then.
Okay, that's fine. But yeah, the preview is, if you notice when we were installing, one of the steps that was on for a few seconds said relocating. That's. Yeah.
Well, if you run Spotify, you see a bunch of like x64 underscore v3. What does v3 mean?
v3 is a level of instruction that is kind of standardized. So x86-64 runs on all the x86-64 machine. Then they standardize v2, which is AVX, if I recall correctly, plus some other instruction. v3 is AVX2, and v4 is some AVX 512 instruction. But if you look for generic x86-64 architecture level, you'll see all the instruction set that are part of this.
There is a JSON file in the checked-out code, which is called microarchitectures.json. It mentions all the Spark.
Yeah, that's our spec. That
When you say like standardized, means that there's
it means that compilers know about that. You basically ask -march x86-64 v3.
So that's supposed to mean something also outside of Spark, right?
Yeah. Yeah, exactly. And it's focused, I would say, on vector instructions as far as I can tell. So, well, for inspecting the environment, I guess we already covered it. You have the Spack find command with all its options that lets you inspect what is installed in the environment. And you can also use Spack Spec, especially if you want to inspect something that you see in the environment and you use -L and you get those short hashes, you can use that on Spack Spec and that will give the tree representation of the thing that you're pointing it to. So let's see if I can take something small enough that doesn't go off my screen. So if you do something like that, that will show a tree representation of GDBM, where the green part means, the green plus means it's installed. I can probably enlarge it a bit. The red minus means it's in the spec, but it's not installed. This is a build dependency. Those are the things that have not been installed. And then you see all the options that are in the real installation that we didn't, specify, basically. So far, so good. Now we are on time. I guess I should move maybe a bit quicker. To remove packages, it's also, I want to go through the entire removing, just comment here, because I want to show a few more interesting things. But to remove packages, you have to go through stages like when you install packages. If you do Spack remove, you just remove them from the environment, meaning they are not part of the root spec anymore. Then you can use Spack concretize to keep the view in sync. And if you really want to remove them from the installed software, you can do that, provided no other environment uses them. So is that clear? Yeah, I guess if I don't hear anybody asking for a proof of that, I'll just go on, because the interesting part is how to share the environment. There are shortcuts to collapse all these steps into a single step, but you have to know what you're doing. Basically, you can use a Spack install -- add that goes in a single step through adding the root spec to the environment, concretizing the thing, and installing it. That is more convenient. It's a single command, but if you slightly mistyped, you installed something into an environment, and now you have to figure out how to restore the previous state maybe. So just to tell you about the layout on disk, before we had a question, where are environments stored? There is this command which is useful to navigate the various directory in Spack called spackcd. -C brings you to an environment directive, and so you can say spackcd -e my project, and that's the environment directive of a my project environment. And if you do an ls, you see that it's basically two files. The manifest file right now is quite simple. It just contains the two things that we wanted to install. It activates the default view. So view controls whether we want to create a view or not. If it is true, it places a single view in a default place. If it is false, it doesn't generate the view. Otherwise, you can configure with an object, with a more complex object that's described in the documentation. But basically, you can have multiple views. I'll show that last in the environment. And then there is concretizer that basically defines all the options for the concretization. In this case, unified through means that all the parts that go into the runtime environment need or must be projected into a single file system hierarchy, so they cannot contain any duplicate node, so to speak. So things that would clash, that would close a name clash when you project them in the view. Unified through basically means, please be sure there are no different configurations of any library or of any runtime thing. And that's for the manifest file. For the log file, it's still let's see if I can type the output without messing. Okay, it's still human readable. The log file, as you can see, contains all the information on what we want to install, including the Spack commit that we used, the hashes of the root files, and then all the details of all the nodes that we are going to install, version, architecture, platforms, all the parameters, and so on. It's human readable if you want to inspect it, but it's meant to be consumed by other Spack commands or by other tools. This one, I think it's 8,000 lines when it's pretty printed. Finally, if you want to share environment, you can do it in two ways. Yeah, still 10 minutes. The first one is to duplicate an environment starting from the manifest. This can be useful if you want to move a stack logically to another machine. Maybe the machine has a different architecture or a different operating system, but you still want the same kind of tools. So your user request is pretty much the same. What you can do is start from a spack.yaml and basically recreate the environment. If you do something like that, what you keep is just the configuration and the, oh, I have to activate the environment. Sorry. I just want to show that now I have two environments. The green one is the active one. I want to activate the other, which I just cloned from the manifest file of my project. And now, if I do Spack find, what I copied are basically just the root specs and the configuration that was in the manifest. If I go on a similar enough machine and I want to reproduce a build, the other thing I can do is to duplicate an environment called concrete from the log file. And if I duplicate from the log file, then I'll basically get the exact same environment. So if I do Spack find, I'll see all the installed specs because I duplicated from the already concrete state with all the details about the architecture, the variants, and so on. But the important part here is that despite that, I am in a duplicated environment called concrete. Yeah.
What would happen, for example, if you would have some, I don't know, CUDA dependent in here?
I would start from a manifest file, so use the abstract thing, and basically just tweak the configuration that I want.
Okay, but then the different.
you want to keep all the others the same.
Yes,
Then you can start from the log file and start removing, cherry picking the one that you want to change. But yeah, I would say I wouldn't be honest if I didn't say your mileage may vary depending how you build the initial environment.
If I understand the question correctly, it's like given a concrete environment, they make like incremental changes.
Yeah.
So we don't really have to for it right now. We're thinking about it because it would be nice to do like solve your big environment with 800 packages at once, and then be able to do like I want to update zero. Just do that. Yeah. So we have some commands, and I think it's like one of them is like stack deconcretize.
Yeah, but
it's still like
deconcretize is deconcretize is basically removing from the log file some cherry pick thing. We are also talking about having some more invasive command, but then question is whether we can still keep the consistency that the concretizer gives us.
Yeah, but the idea of starting with one big resolved environment and then doing like incremental changes, like your Linux distribution, basically, that is something that we're discussing. So if you have great ideas about what it should look like, then happy to listen to those ideas.
Yeah. Our ideas are not great.
So, but basically, those are the ways to share the environment. And the last thing that I want to show you is a new feature that will land in Spack v1.2. And that's to showcase that despite the fact that we just used the list of things that we want to install, the manifest file also contains configuration. So what I want to show you now is showcasing the simple use case. Let's say that Ubuntu provides GCC 15, but we want to build with the latest GCC that was just released last week. So what we can do, and we want to do that in an environment, what we can do is basically attach configuration to the manifest file and use a new feature that will land in Spack v1.2 called named group of specs. So the list of things that you can install in an environment can be partitioned into named groups, as you can see here. Here I created a group named compiler, and the compiler is GCC 16. And then I have another group called GCC 16 specs, and I can establish an ordering dependencies between these groups. So I have all the concretized specs of one group available when I concretize the other. And by doing that, I'll be able to concretize Quantum Espresso with, using MPI-CH as an MPI provider with extra configuration to prefer to use GCC 16. And for now, we'll just turn the view to false, because as I said, with more complex configurations, there may be clashes in the view. There are clashes in this view. And when we concretize, you'll see that we concretize GCC 16 first. It will take a few seconds, then it will move on to Quantum Espresso. And when you install it, like if you're really building it, it will build from GCC 15 up to GCC 16 up to your Quantum Espresso. And that thing that I'm now showcasing can be, extended to an entire stack that is deployed on HPC systems. So, and here we are relocating GCC because that was one of the things that we asked for. And yeah, I don't want to steal too much time to the next session. Just want to leave you with the fact that with more configuration, you can basically set up different views, like in cases like this. If you are using it for your own profit on your workstation, you can set up a more complex configuration for the views, and you can decide that will generate two views. In one, it will have the quantum espresso, and the other one, the compilers. And at activation time, you can decide which view you want to have in your path and so on, depending on your use case. So if you have build tools and applications, you can select which one you want for your sessions. And you can find more information in the links at the end. So I don't know if you have any questions on that, but basically this is a new feature that lets you bootstrap a compiler, have a specific configuration for that group of stacks and so on. To define, to specify it on the spec. Yeah, it's target, like when you specify something, target equal, and then you have a list of names that are known. To get them, it's Spack.
I'm no longer sure. So this one, right?
Yeah, exactly. And to know all of them, it's Spackart -- known targets, I think. But yeah, double check because I don't know that.
Should I take it from here?
I don't know. Are you in the same session? Do I need to go out just to? Apparently, it's unresponsive. Well, let's see.
I think
I won't touch it.
I'm back. All right. So usually we do a section of creating a package, but looking at all the packages that we've seen for material size, etc., usually things are already packaged. And if you work with spec packages, then very often you just read them or edit them. But for the sake of the tutorial, it would make sense to look at a real world example. So far in the environment tutorial, we have just taken packages kind of for granted. They exist, and there's a solver resolving dependencies and whatnot. And now we're going to look at how these dependencies, etc., are defined. So I'll be doing this with Quantum Espresso again. And hopefully I'll get a bit more of my screen shared with using two screens instead of one. So, all right. I typically make an environment locally. I think there was basically also a question like, where do two environments go? You can make an anonymous environment, which is more like virtual environments in Python if you're used to that. So if you specify a path as the last argument, you get a environment in your current working directory. So I'll activate that. And I'll edit I'll just copy and paste an environment to get started. So you can either use spec config edits, and it will, in the obviously wrong. Yeah, I know how to exit email. That's great. First of all, you do export editor equals vim, and then you do sorry, that was and from here, I'm just going to paste that environment that I got from the tutorial. I'll concretize once more. Let it run. And we'll be looking a little bit what the concretization now actually looks like. So there's a whole lot of noise on the screen. It's still running. If you scroll all the way to the top, you see, okay, there's quantum espresso, great. It has a bunch of variants, so that's sort of like the tildes mean without, and the pluses, if there are any, like OpenMP means with OpenMP enabled. Scale is apparently enabled by default. So yeah, you'll see all these variants, and they are defined in the quantum espresso package, and we'll be looking a little bit more about what that's about. One of the things you'll notice, so here's like the trimmed down version of that output. Alpha, for example, the eigensolver, is disabled, and we'll soon enable it and see how that interacts with dependencies or optional dependencies. Instead of directly concretizing and then figuring out what variants exist, you can also use spec info, quantum espresso to get more like of a high-level overview of what's there, like a structured version. So you get a description, a home page, you see like the preferred version where the sources are fetched. You see a whole lot of variants that you can influence, like enable, disable, set a string value, whatever. And you will also see the default values. So for example, CUDA is disabled by default. A whole lot of things are conditional in spec, and that will probably be one of the takeaways from this half hour. Pretty much everything is conditional. Like when a certain condition applies, then you have a dependency, or when a certain like target architecture is used, then this sub feature of the package doesn't work. All these things are conditional. So where are all these variants and rules basically defined? Well, then you have to open the package. And we have a command for that, which is spec edits quantum espresso. And it will land you in an editor with in the bottom, you can see that it's, well, where the file is, was basically in the built-in repository quantum espresso package. And the package is defined as a package.py file.
So does that mean that you're editing what's installed? So you're not keeping a copy of the original or anything like that?
This is the package repository, but that is what everything is read from on installation or in concretization.
That's basically the recipe that we are editing. When we install something, we copy the recipe that was used to install it in the installation directory to keep track of the fact that that was the recipe. Here we are basically changing the recipe in the repository.
So if you open the package.py, the structure is kind of like what we already saw in spec info. So here you see the description, some URLs. The Git part, it becomes also relevant. URL is basically where to find tarballs with the sources of releases. Git is where to find like the development versions, and we'll also talk about that tomorrow. You will see that one person in this room, at least, is a maintainer of the package. And here already you see something interesting. So there is this thing called build system. It's a directive. And it's something, again, conditional, like it turns out that at a certain point in time, Quantum Espresso started using CMake, and before they had only like a configure script or something like that. And I believe right now they're both, so you can install it with CMake or you can install it with configure script. If you do an installation with CMake, you might get like slightly different install than if you use the configure script. So how we model that in Spack is we have a variant called build system, and you can set it either to CMake or to generic. And we allow users to say like, okay, only from version 6.8 onwards, you can use build system CMake. That also means that dependencies, like build dependencies, are immediately conditional. So if you use the generic version, you don't need CMake as a build dependency. So even like depends on CMake, like I don't think we have it exactly here, but dependencies also have like this when equals build system equals CMake, then you depend on CMake. Scrolling a bit down, we see something about how Spack models languages and compilers. So C, CXX, and Fortran are languages that are all used. I think it's mostly Fortran, but in the quantum expressor case. But if you specify depends on C, it means this package needs a C compiler. So it pulls in a dependency on GCC or LVM, etc. I'll skip over this. And here is, for example, a rule where you see a certain version of CMake is needed as a build dependency, but only when the build system equals CMake. All right, and if you scroll down all the way, there's going to be dozens and dozens of rules that are basically sourced by the community over time, and at some point packages start to really look like this. I want to go all the way down because okay, there are patches, dependencies, and ultimately we find two things. There is another class called the CMake builder, and there is a class called the generic builder. So the generic builder is basically for the old way of installing QE using a configure script, and the CMake builder is for if you choose a CMake build system. And basically all you have to specify as a user is like what arguments to give to CMake to start a build. And also that you like the arguments you specify are conditional. Like for example, did I enable MPI? Yes, then I should pass QE enable MPI. So it's like a helper function defined from variants that goes like QE enable equal QE enable MPI equals on or off based on the value of the variant. Right. I think this part of the package looks kind of clean, so it's nice. All right. So we've seen a bunch of directives now, like maintainers, the build system, versions, depends on variants, and how they're used. So in your environment, you can now also toggle these variants. So as we saw before, hopefully you can do, yeah. Spack outputs this whole tree again. Like if I go all the way to the top, you notice that alpha was disabled. So tilde alpha means no alpha. And if I want to change that because I like a faster eigensolver, I can add plus alpha. And then I would concretize again, which takes a second. And now we're going to end up in a bit of a funny situation where Quantum Espresso uses OpenMP by default. Alpha, the eigensolver, supports OpenMP. However, if you look at the output of the concretization right now, excuse me for all this noise, we should probably make it condense it a little bit. So Quantum Espresso now has plus alpha as we specified. It has now an alpha dependency, not yet installed. It's lacking OpenMP support though. So that sounds a bit curious, right? If you have Quantum Espresso with OpenMP, then why don't you have alpha with OpenMP, right? Just for the idea, I will install it. So in this case, it literally just added alpha as dependency, so that we have to install, and then Quantum Espresso on top of it. All right. So why is it that Quantum Espresso does not immediately give us an alpha with OpenMP support? It turns out that this is not a bug, but it's just the fact of life. It just happens to be so that the CMake build of Quantum Espresso is right now does not support an alpha with OpenMP. So if you go through the rules, it is actually being written down by somebody. All the things related to alpha are roughly this. You have a variant alpha, it defaults to false. We change it to true. It is only available when you also have scale effect, fine. But when alpha is enabled, so there's somewhere in the package, we have an explicit dependency depends on alpha without OpenMP if the build system equals CMake. So this is super highly specialized on the build system and very, very specific. However, if you have build system generic, so the old configure script, then it's fine to depend on alpha with or without OpenMP. So I'll show you in a second why this was added, but for now, I'm just going to show you that if you really wanted to have
One question.
yeah, there is a
Could you not change these two depends to conflict statement?
yes.
Now it basically says always alpha, but not the OpenMP version when not OpenMP is configured.
Yeah, so when to use depends on, when to use conflicts, when to do requires, it depends on the taste of the package offer. So in principle, conflicts are a bit less restrictive. I think that's what you're saying, or yeah. So sometimes you want to say like conflicts alpha without OpenMP if you use OpenMP. Well, people have different tastes and preferences, so I'm not going to argue against what the Quantum Espresso package offers. Like,
Just wondering, so this knowledge now is in here, and there's Quantum Espresso developers in the room. Is this knowledge in the build system of Quantum Espresso? So if I did have an output that open in key inside, does anything fail, or will it?
We'll see that tomorrow.
do I not have it here? We can do like.
I think we use the other comment.
I can probably give away why it's the case.
Okay.
It just happens to be so that alpha installs a different library name if you enable OpenMP. So it's like lib alpha with OpenMP dot library name. And the CMake build is just not aware of its facts. So it will just fail to locate alpha. It's looking for lib alpha.so instead of lib alpha OpenMP.so.
Yeah, tomorrow I'll ask you to pretend you don't know that.
Basically, this section is a setup for package development. So, yeah. But point is rather that if this is like an unovercomable problem in the build system, at least you can specify it in spec that you cannot, if you use build system CMake, use Quantum Espresso with alpha and OpenMP. So that is like the level of detail that we can specify.
Comment from somebody in the team student. I saw it pop up, but I didn't read previous work mentioned.
Something with the, I mean, it doesn't matter because this is a use case, right? That you cover now. I think it's saying it's covered. It's support is there now.
Yeah.
Oh, okay.
Yeah. So okay, that's good. In any case, suppose that we really want to have this alpha with OpenMP. One thing you could do is do like %, which means in spec 1.0. I don't know if everybody's familiar with that syntax. It means you specify a direct dependency. So % direct dependency. It is pretty similar to what people have seen probably a lot. This means like a dependency somewhere down the line. This means very concretely direct dependency. So you can say like, I want Quantum Espresso to depend on alpha with OpenMP. And I would concretize that again. And then it turns out the only way of doing so is by not using the CMake build system. So we should speed up the concretizer.
Yeah,
so not have this awkward moment of suspense.
Yeah, we already did a bit, but
yes,
we have slides proving it.
So going all the way to the top again of this concretizer output, we now have Quantum Espresso with alpha enabled. There is a dependency on alpha and it has OpenMP enabled. But the cost of this is basically that, it's like halfway down this line, but that we had to also switch the build system to like a festival build system. So is everybody still with me, or I'm just rambling in front of a computer now?
What happens if it says no, if it is can't do that?
you will get either a nice concretizer message that the two things are conflicting, or it says internal error. And
yeah, I mean, you can get a nice concretizer message, a very bad concretizer message, or an internal concretizer error.
So,
And last one says, please stop with talk.
yeah, exactly. Please submit an issue.
please see your therapist.
This shouldn't be happening.
Sorry, just specify this system as
Oh, build system generic means that, well, do you want to take that?
Yeah, it's basically, it just means like an unspecified build system.
okay.
So very often it's build system equals CMake or build system equals auto tools.
Mason,
I think in this case of QE, it was like a handwritten script.
configure script, yeah.
So it is generic. So it's like whatever.
Okay.
Generic basically in our land means that you are in charge of writing enough Python to make it work.
Yeah, so what that means concretely,
Yeah,
what it means concretely is if you look at the package, go all the way down, you will find this builder class. It is awfully long. So generic builder. And this is what's being searched for if you have build system equals generic. It will look for generic builder and then run install.
Continuous press actually resulted, if continuous script is which calls the under, so in this case it's not.
Do you mean like it is actually auto tools?
Yes.
Okay, so somebody can change the package.
that can be something for the hackathon on Thursday.
We can make improvements to the package afterwards. But yeah, anyhow, personally, I think if you just look at how much flags and whatnot is needed for the old configure script, it's probably a wise choice that CMake is now the default because it's just a handful of them. So where am I? So yeah, we set the ELPA to use OpenMP explicitly, and out we got a different build system because that was the only one that was supported. So I think I'm even a bit ahead of time. What we've covered, just going through this package, is all the version directives. We've seen different variants. We've seen depends on statements with constraints extra on them. Like depends on ELPA with OpenMP or without OpenMP. We've seen this with when thing, which I didn't really have that much, but it means like everything in this block only applies under this condition specified. We've seen build systems, like one package can have different build systems. And didn't touch much on it, but yeah, requires and conflicts are also part of the rules you can define in a package. So this is basically a setup for day 2 where we introduce development workflow. I hope that's interesting to people who work with Spack more regularly for like as a scientific software developer. And basically we're going to show 2 things, like how can you use Spack to install Quantum Espresso with local sources, like your local clone, for example. And also like how can you, like suppose you've done a change to Quantum Espresso to make something work in the build system, and you submit a pull request or a merge request on GitLab, how can you patch like already released versions to benefit from that change too? So that will be for tomorrow. Then I think we still have a little bit of time, like 5 minutes for questions. Question.
Yes, I see in the package recipe, there's only one URL.
Yeah.
That is my URL for one table for one specific package. The Spack then.
So if the naming is regular, we infer how to change the versions and we just generate the other URLs. If versioning changes, you know, the name of the tarball changes across versions, then we have more complex ways to instruct Spack that from version X, you should interpolate this URL, from version Y, you should use the other URL and so on.
Yeah, so Quantum Espresso is great because it has everything. So it changed from GitHub to GitLab. It has one release where somebody named the version like slightly differently. So
Yeah.
so then you have an exception to the rule.
Somebody should give a talk on funny stuff.
Yeah.
Yeah.
But basically what matters, so what matters mostly is that this, I cannot select anything. Like the checksum is given, so no matter how the URL is, you just are guaranteed to get the same source files.
Just a question. So now that we know, but it's spoiler for tomorrow, the Alpha has a different library name, right? It's OpenMP. Is there a reason that you wouldn't build both then in Spack and say both are there because they're different library names, right? So is there a reason that you wouldn't?
You mean different packages or?
So then the question,
With and without OpenMP can be the same package, right? It can be shipped in the same installation.
Oh, okay, okay. Yeah,
I think it's also a matter of build system support again. So,
and package maintainers, because I think we do something like, it's probably FFTW, where the package maintainers went his way through building all the different flavors and installing in the same place. The Alpha maintainers basically said that's, if you ask for OpenMP, you get OpenMP. If you ask for not OpenMP, you get the other.
But if Spack knows about two variants, there's no way you can install two variants in the same installation prefix under the same hash.
No,
Yeah.
there is no way. But you can say that plus OpenMP also installs the OpenMP. That's like, you give meaning to the variant.
yeah, so I think it is a matter of how much effort does the package maintainer want to make. So in principle, you could run the build twice.
But I guess it's hard for that information to trickle down to other people, to other mail. Like somebody else is using this dependency. How are they going to know that? Like if you go and do this one day, how does the information trickle down to somebody who maintains another package?
Yeah. So I think with Alpha, it's not necessarily horrible that you would have like a second build. I think it doesn't take forever, but it's a fair point. Like, for example, blast libraries that use a different integer type or something. If a cornerstone package is important and has two flavors, then it has like a wide influence on everything built on top of it. So that is sometimes a bit annoying with the fact that you happen to have something installed, but now you want a slightly different variant of the same package. You need a different variant of the same package for something else. Well, okay, then everything in between has to be reinstalled.
Is that a quote I can use in the blog post?
Oh yeah, well, if you want to pick on a package like that, you should look at Boost. So there are people that says, hey, to build my package, I just need this minimal version of Boost, nothing else installed. But then, other packages come along. And so the reality is that if you want a single installation, you have to install everything. And so
I think the way out is like if you have a big environment with everything that you need and then say unified through, then all the variants, like there should be native fixation. So that's one way. Other questions? Yeah.
Regarding installing a package, a group of packages that it's an environment, is it possible to install all of the packages within the environment? Let's say, for example, in my instructor jar, I specify Gromas, Nandi, and others. I see that the command that you shows Spack install first. If there is a way to install all of them without specifying one by one.
you mean everything that is an environment? Yeah, I think we have flags for that.
Is it possible?
I think so. Like,
You would have to check it.
yeah, I need to check it, but Spack and install -a, I think is environment aware.
I might not entirely recall the question. So.
She wants to wipe out an environment, but only the things that are in an environment.
I think you can meet the specs and it installs everything that you compile in the environment. install minus.
No, uninstall, I think. She was.
Uninstall.
Yeah.
All of the packages that sometimes happen.
Oh yeah, so for example, with a dash capital E, and I do find that's like everything outside of the environment, everything I've installed is 63, but in my environment itself, I have only 39. I think if I just do install all, then it says the following environment still references these specs. Or was it spec GC? Well, if I would remove this environment just to be like okay. I think everything is still referenced somewhere, so
Yeah.
I won't be able to uninstall everything in my environment because I still had another Quantum Espresso already installed that still used the same thing. So, but if I had only my environment and nothing else used stuff from the same environment, I could do spec and install -all, and it would just say like install these 39 instead of everything.
Yeah.
I mean, if the tool is missing, you can just move the environment's dependency.
Oh yeah, no, that you can do. That you can do for sure. And there is also spec GC if you just want to claim your environment.
Yeah, spec
GC garbage collect.
It has flags that I always forget what they're doing, and they're very long, and if I read them, I have to read them twice.
Yeah.
But it can be used to like keep only what is in my environment and everything else, delete that. Or yeah, so I'm always confused with what accept any environment means, but there are some tools to like do the different Venn diagram overlaps of the environment database.
Do you have any options to see how much space you're using, how many inodes you're using, or anything like that?
That's a good question. So because we have everything in one store, there is a built-in utility.
Yeah.
But there have been some like questions like are
follow the siblings in the view, what?
So that is a new thing in Spec version 1.2. We're inode aware now. So there was like a common complaint that if you use environment views, then as many files that you installed in the database or like installed with Spec, so many symlinks you get as well. And that was actually adding up. So like if you create a container image or something, the symlink will actually take quite a lot of space. Or if you were doing the home directory, that was taking a lot of symlinks. So now in Spec version 1.2, our symlinks are actually, like we're no longer doing that, one file, one symlink, but rather like if a directory is very much unique to a single package, we symlink the directory. And that cut it down by like 80% or so. So now, in terms of how many inodes we use, it is mostly from the installations, and views are small. Do people actually run into inodes restrictions? Yes?
Always.
Yeah. All right. I think we're out of time for this section.